Hi, it's Ken from shop3d.ca. Welcome back to another monthly webinar. This time we have a material with us, and that is Forward AM's TPU lineup. Now, TPU has always been a very interesting material. Everybody calls it a rubbery material, a soft material, a bouncy material, but there are actually a lot of practical applications for it. It's very good for wear and tear resistance. It's very good at resisting oils and other chemicals. And of course, it's very good for doing soft things. So my team is going to take you through the TPU lineup from Forward AM, and we're going to talk about what this material can do for you.
Hi, I'm Pooja from Shop3D. Today I'll be talking about Forward AM Ultrafuse TPU material. TPU stands for thermoplastic polyurethane, which is a versatile material for flexible and elastic 3D printing materials. Basically, ultrafuse TPU material is being tailored by chemical structure of altering soft and flexible material, allowing them to control the hardness, flexibility and strength, as well as the cold weather performance. Here at Shop3D, we use this ultrafuse TPU very often, such as the 95A, 85 as well as 64A. These materials have very high wear and tear resistance, as well as these are very tough against oil, greases, as well as a hard environment. Let's take a quick overview of these materials. 95A is a great combination of flexibility and durability, making it more ideal for the beginners who want to start with the 3D printing with the TPU, as it is very easier and faster in printing. This can be used for both direct drive as well as a Borden type of printers, as it is also having a wear and tear resistance, can be used for applications such as tubes, seals, as well as a bushing. Next is 85A. This material stands out because of its excellent flexibility, and it has a high impact resistance, also high damping, like vibration damping properties, making it ideal for applications such as footwear, sports equipment, as well as clothing. And this material is also great for users such as an intermediate level of TPU printing. Lastly, 64D. This is a great alternative for rubber and ABS-like material, making it ideal for applications in industrial manufacturing such as tools, jigs, and fixtures. This is also a great option for the users if you're having very intricate TPU part, and this supports the soluble support material. So it would be a great option for the intricate TPU designs. In summary, each TPU has an unique property, making it suitable for different applications. Up next is Michael, who will be demonstrating some of the TPUs for you.
Hi, I'm Michael from Shop3D. Today I have a selection of airless basketballs, shrunk down of course, to show off some of the materials from Forward AM Ultrafuse. Namely, we've got two different hardnesses of their TPU. We've got 64D and 95A. And just as a reference point, I also have one here printed from their PLA. So starting with the PLA, it's very hard, has no flex at all really, and is very typically what you would print. It's pretty normal filament. Whereas if we move on to the TPU, this of course has the main use case of being a flexible material. So as you can see, can flex it and it will have a bit of give. The 64D is a bit tough, still has flex, but won't be nearly as soft as the 95A, which is very easy to kind of just push around and change its shape. To give you a more direct comparison, if we squish these two balls together, you can see that the 95A gives a very obvious give before the 64D. If you want to print something that has more flexibility, you'll want to go with something like 95A or maybe even 85A. Whereas if you want something with only a little bit of give but still has some flexibility, you'll want to go with something like the 64D. I hope that's giving you a very kind of hands-on demonstration of the difference between the two hardnesses. If you have any questions, you can feel free to reach out to me at michael@shop3d.ca. Next, we have Shaw with a use case presentation.
Hey guys, my name is Shaw. I work in the technical service department here at Shop3D. Today, I'm here to talk a bit about Forward AM's Ultrafuse TPU filaments. The Ultrafuse lineup has 3 variations of TPU filaments, each for its own sort of purpose. There is 95A, which is a common TPU that most people are familiar with. 84A, which is a softer TPU than the 95A. And there is also 64D, which is a slightly stiffer material that Ultrafuse offers. I'm going to talk a little bit about a case where I'm helping out a friend of mine. He's super into RC off-roading, and traditionally RC off-roading, they use tire inserts, and they use sort of a foam-like compound as the tire insert, and basically it just goes inside this tire. And more recently, within the past couple years or so, there's been a sort of innovation in the space where people are 3D printing their tire inserts, and this offers an advantage over the foam inserts because you're 3D printing, you can more or less control where you want the tire to be soft, where you want the tire to be more stiff, and thereby giving the tires more traction over the ground that you're sort of driving on. And so I came up with this design for him after looking at some of the stuff on the market. Now, a couple of things I'll talk about in terms of what I experience when making this tire insert. One, he told me is you would prefer the outside to be relatively soft, and you want the core to be more stiff. And essentially ideally what you want is you want the outside to be able to squish, while the inside core is able to maintain that circular shape. So that's the ideal sort of design. The second thing is these tire inserts are 3D printed tire inserts are I would say relatively expensive. They're about $50 Canadian for a set of 2s on average if you take a look online. And we can make these out of the filament, I would say about $5 to $10 worth of materials. Print time is usually about 6 to 7 hours for something this large. This is a fairly large size tire insert for this. The other benefit is you can go in and you can sort of custom, if you have your own 3D printer and you have this material, you can sort of test different types of patterns to get different sort of feel in your tire. To place the insert inside the tire, it's relatively easy. You just squish it in, basically, like so. Right, and there you go. So this can be mounted. There's 2 more pieces that basically hold the bead of the tire to the shaft, and that's it. That's a completed tire, and he can go and test that out, and then we'll move on to a next iteration. So that's the benefit. Okay. Another use case is in orthotics. So recently I've encountered quite a few customers that are interested in producing their own custom orthotics. Sometimes there'll be heels, sometimes there'll be inserts. And what I have here is a demonstration. So this this demo piece is printed with TPU, and you can see it's relatively flexible here. All right. Now this one is done with 64D, and it's a little bit more rigid, which is nice because it'll hold its shape as a heel insert. So this is another sort of use case that I'm seeing quite often with the TPU material. A little bit about printing with flexible filament. It can be a little tricky. I have a couple of recommendations. First, we want to make sure that the filament is dry before we load the filament into the printer. You can use a dryer, or you can package it in a vacuum package with some desiccant that is fresh, and that'll help with preserving the humidity level of the filament. You do want a very low humidity level when you're using TPU. The next part is something that I would prefer. I would prefer to print TPU with a direct drive printer. And the reason why that is in a direct drive printer, the distance between the extruder gear and the hot end melt zone is much closer, as opposed to a setup that is a Bowden tube, where the extruder is almost, a few hundred millimeters away from the melt zone. And because of that distance, it's difficult to control the flow rate, and sometimes what you'll end up with is a little bit of under extrusion. Another tip here is cleaning the hot end, making sure to get rid of any excess material in the nozzle. You can do this by one of two ways. One, you can do what's called an atomic pull, where you use something like a nylon filament to sort of purge the system and then pull any sort of gunk out. The other method is just by purging the nozzle for an extended period of time, usually about a minute to a minute and a half or so, where I recommend using e-sun cleaning filament, and you just basically keep purging through. So basically you load a filament, you load the cleaning filament, and just keep purging through the nozzle for about a minute or so. And that usually gets rid of any sort of leftover material from previous uses. And the reason why you want to do this is so it doesn't compensate when you use TPU. The system basically has a measurement of the volumetric output, and you don't want to sort of deviate from that because of any excess gunk that's inside the nozzle. Okay. This is not so much, what I'll talk about next is not so much a recommendation, but some of the things that you can do or settings that you can look at in your slicer to yield different types of results when you're using TPU. So I recommend trying a variation of different infill patterns, also different infill percentages, and last, different wall amounts or extrusion amounts. Basically what this does is, like, if you make a thicker extrusion or wall, TPU will be less flexible, more stiff. At the same time, if you change the infill percentage, it'll change the basically the way that the material is gonna squish, I would say. The other one is a percentage. So obviously something that's very dense is going to feel much stiffer, and less dense is going to feel much more squishier. Okay. One other thing that you can do with TPU that is interesting is you can put it in combination. So I use ABS with TPU. This is commonly done because the materials are actually pretty compatible with each other. So you have ABS as sort of the stiff section if you need something that's stiff, and then your contact surface can be something soft so it doesn't damage any other surfaces when it comes in contact with it. And you can use TPU for that, and this will give you a more softer contact surface. And you can do it with something like this where, you know, I'm making a thread on the, this is supposed to, I guess, a light bulb. So the thread is much stiffer, so it'll hold itself in position, whereas, you know, where the light bulb is relatively soft. There is a function in Cura where it'll interlace in the G code of the two materials to make the bond a lot more, a lot stronger, and that's beneficial as well. Yeah, so I hope you got some information out of that tips that I've offered, and let's try to print some stuff in TPU.
Hi guys, welcome back. So we have a couple of frequently asked questions on these TPU materials. So let's get into it. So Michael, my question is, like, lots of people want to start with the TPU printing. So what's the best material to get started with?
Yep. So obviously it'll depend on your application, whether you need something harder or softer. But in general, you'll typically have an easier time printing with 95A or 64D since they're less flexible than materials such as 85A.
Can this TPU material be printed in the different type of style?
Yep. So TPU you'll have better control when printing with a direct drive printer, but you can still print it with a printer that uses a Bowden tube, such as the Ultimaker S7.
Oh, okay. So what does that letter mean in front of the TPU with the number?
Yep. So those are actually the Shore hardness scale. There are two of them. A is typically used for softer materials and D for harder ones. And the number also indicates where on that scale it is in terms of hardness. So for example, 64D will be harder than 95A, and 95A will be harder than 85A. So I've got some questions for you as well, Pooja. My first one is, do I need to dry TPU? Like, does it? Like, I know some prints, some plastics print better when they're dried. Is TPU one of them?
Yeah. So when you have it like a brand new sealed pack, then you can use it for the first interval of time. Then after, if you have kept it for like certain amount of time and you have not used it, then it is best recommended to dry it to get a good quality prints.
Okay. And am I able to print more intricate parts with the flexible material?
Yeah, there is one TPU material from the Forward AM, that is 44D. This supports soluble support material. So if you're having something very intricate TPU parts, then you can use this material as a great option to print those intricate parts. Yeah.
All right. And what else can I do to get good print results from the TPU material?
Forward AM offers a lot of print profile on their websites for very popular printers. So you can look up on their website. It is great to download those print profiles, and that will be a very quicker way for you if you just don't want to struggle with any the features in it.
All right. Thanks so much, Pooja. Next up is Ken with an exclusive offer for attending this webinar.
So by now, I hope you've learned a lot about the applications for TPU and what it can do for your specific business. If you want to try out these materials, this is a great time to get into it. We have either 2.85 or 1.75 millimeter diameter filament. Whether it's for your Ultimaker, Raise 3D, Bamboo lab printers, you can use TPU on those printers. We have on sale TPU 95A, 85A, and 64D. And until November 30th, if you use the coupon code below, you can actually get 15% off these filaments. So make sure you take advantage of that. Thanks again for joining us for this monthly webinar. My name is Ken from shop3d.ca. If you have any specific applications that you want to discuss with us, whether it's about printers or materials, make sure you contact our team directly. We're more than happy to help. Thanks again.